Okay, in this video I'm gonna cover a calculus 2 um, for a hyperbolic. So in here it says sine angle is equal to e to the I angle minus e to the negative I to the angle all over 2I. So the sine angle for this calculus hyperbolic, you use only this when you are like doing a sine function of data, sine function, whatever is gonna be here, x or t or angle, sine function, this is what we mean function of data. So you're gonna use it for this. But what about sine function? But if you change the angle, the function of x is gonna change to the, you change the instead I angle x, so sine hyperbolic. This is when you're doing sine function, I should say here angle, sine angle of data, angle of data, you're using this. But when you are doing hyperbolic, so sine hyperbolic x, then it will be e to the x negative e to the negative x all over 2. So yeah, that's how it is. But what about the if you're doing derivative of the sine function? So if you're doing a derivative of the hyperbolic, derivative of the hyperbolic sine function, I think is sine, I should say derivative of uh, derivative of let me say derivative of dx, right, for sine hyperbolic x equal to is cos hyperbolic x. So this equal to this. If you were asked do the derivative of sine hyperbolic x, you will say this. If you were asked, do the cosine hyperbolic x, you will do this. It should be a table that tells you. So this is the derivative of function with respect dx sine hyperbolic x equal to cos hyperbolic x. So this equal this. It's like I'm saying like 2 equal to 2. So this is equal to this. So this equal to this. Whatever you have here. For example, here you were asked f of x cosine hyperbolic x to the power 4. So and they were asked to do the derivative of function dx because this is x. So now they ask you to do the derivative with this function, basically derivative cos hyperbolic with this function. So we say in here this derivative of this is equal to this. So you're going to say derivative of f with respect dx equal to sine hyperbolic x, because I replace the cosine here, I replace sine because I'm saying they are equal. Cos x to the power 4 times, now I have to do like I was doing the previous lesson, inside derivative x to the 4th, calc 1 is 4x cubed, because you have the 4 coming and you subtract 1, x cubed, right, x will raise power of 3. So this is the derivative now. And then it comes to the front because it has coefficients number. So we have derivative of df with respect dx equal to the 4x to the power 3 sine hyperbolic x to the fourth. So this is the how you do the derivative equal to for a hyperbolic sine. So basically sine hyperbolic x is equal to cosine hyperbolic x. So if we have to do derivative of sine, we get sine hyperbolic x. If we have to do derivative of sine, we can replace to the x. So we did here, and then the function itself we did the derivative. So we did derivative of cosine is sine hyperbolic x to the power of 4, and then we did the function inside, we did the derivative of that, we got 4x to the power of 3. So this is the final. Next lesson will be integral. So we see the derivative. Now we're going to see the integral for the next lesson.